Okay, so a primary school in England gives this information. There's 1.4 meters with a standard deviation of 0.15. Determine which of your statements are true and false. Student measuring 1.6 meters is 0.2 standard deviations above the mean. Well, when you're talking about distance above the mean, then basically you're looking at calculating a z-score. Z-score is a certain value measuring 1.6, that's the x. 1.6 minus the mean of 1.4 divided by the standard deviation of 0.15. We subtract that. It's definitely above the mean because it's a positive number, 0.2 over 0.15. That's not actually going to be equal to 0.2. I'm having a hard time here drawing numbers. 0.2 divided by 0.15 is going to be something in the neighborhood of 1.6 bar. Okay, or I think that's actually 0.75 now that I look at it. No, 1.6 bar. I think I got it right. Let me just use the calculator here. Yeah, 1.3. Sorry, 1.3 bar. So it's not equal to 2, so therefore this is a false statement. Student measuring this is that many standard deviations below the mean. Well, let's take a look. Again, calculating the z-score, 1.13 minus 1.4 divided by 0.15. So I'm going to just go straight to the calculator this time. And I would do this. 0.13 minus 1.4, hit enter, and then divide it by 0.15. That's 1.8, and it's negative. So 1.8 standard deviations below the mean, that is true because that's equal to negative 1.8. Student measuring this is that many standard deviations below the mean. Do I need to go there? Well, I'm just going to say false because 1.73 is bigger than 1.4. You don't even have to go through the calculations. Okay, so make sure you understand what you're doing. You know, the answer might be a positive 2.2. So just make sure you understand above or below. If this number is bigger than average, then there's no way it can be below mean. You don't even have to look at the numbers really. So look at that. When we're talking about above and below average, I'll do this one really quickly while we're going because that was a pretty quick little deal. If you look at the normal model and you're told that it has a mean of 125 with a standard deviation of 11, now that means one standard deviation above is going to get me to 136 and one standard deviation below is going to be at 114. And we're told what's the percentage of patients that are at least 120? Well, 120 is going to be somewhere in between here, and it shades to the right. Now, I just got to tell you, the more I can tell you, the better. These pictures look different, not only because this one's drawn better than this, but this one's shaded to the left, and this one here is shaded to the right. Okay? If you use the table, and anytime you're asked about percentages, you're going to use the table. You're going to get an answer that is less than. Okay? This is asking for more than, or at least. Okay? So be aware of that. But this table here is called a z-table. To use the z-table, you need to calculate a z-score. So let's do that first. That's the 120 that we're asking about here minus 125 divided by 11. That gives you a negative 5 over 11, which is equal to negative 0.45. And it repeats 0.454545. Anyway, that right there is your z-score. It's so important for you to understand what it is you're looking for and how do you go ahead and answer the question. This is not a percentage. It's a z-score. Okay? In here, your percentages come by looking in the stripes. You find the z-score on the sides and across the top. However, since this z-score is negative, you got to go to the other side. You got to go to the negative z-scores. So negative 0.45, negative 0.4, and then over to 0.5, and you look up, there it is. Your answer is 0.3264. Now let me write that out. 0.3264. Now let's take a moment for a second. And if we understand that the shaded region is what we're looking for, but the calculator or the table just gave us the stuff over here. Okay? And it makes sense. This is less than 50%. It's off to the side of the average. So this is smaller than what I would have expected if I was expecting this as my answer. You just need to keep in mind that this is a 1 minus situation. 100% of data falls under that curve. So if it just gave me this section on the right, or the left, if I subtract that from 1, it's going to give me the whole section on the right. Okay? You take 1 minus this, and it's going to give you a 0.6736. Now I want to show you something that's kind of cool that you can either utilize or not. If you know you're going to use the other side, if you know it says at least or more than, one thing you can do is take that negative z-score and say, well, you know what, if I'm going to the other side, instead of the negative z-score, let me look up 0.45. And if you look up 0.45 on this table, 0.4 and over to 5, and you line that up, look at this number right here and compare it to the answer. 0.6736 is the same answer you get if you look up the negative one, which you should have looked up, and subtract it from 1. That only works to change the sign of the z-score if you're looking for at least a number or more than a number, because you're looking at the opposite side. And so that's just a little handy dandy trusty dusty thing. Don't let that throw you off. But there you go.